Alright. Alright, good. So, I think our last class, we either have completed rounding up. We have completed standard form. So we completed. Okay, so we're going to do a recap, right?
Yes.
So we're going to do a recap on that. So that means, so we complete fractions already.
Yes, sir.
I'll complete decimals and decimal operations. Okay. So that means we should be going on to percentages today. That's the topic today. Okay, so we're going to do a recap. Alright? I do have an immediate announcement. Did I tell you when you're going to get an assessment?
Yes, sir.
We did that for you. 10th and 8th. 10th. Which is a Thursday?
Yes, sir.
That's next week Thursday. Okay. That's fine. That's fine. Alright. In all my classes, I have to learn each other. But there's always going to be like that 1 or 2 or 3 new students that are here that wants to feel a little bit comfortable. We have a new student here, and we have a nice young lady at the back. And I think we have this gentleman here, and we have this nice lady here. That's 4 new students. So class again. Anybody else new? Still getting used to the faces. Still. Nobody's new. Alright, so welcome, and I will put my name in the class. Okay? So, in our last class, we looked at approximation. And approximation, I'm going to keep it easy. So we looked at 3 forms of approximation. 1, we looked at rounding off to a certain amount of decimal places. We looked at rounding off or approximating a certain amount of significant figures. And we also looked at writing a number in what is known as standard form, or what some of you guys will refer to as scientific notation. Just to get everybody comfortable with where we were, considering that you're new, we'll run through 2 examples of all 3, just so everybody can get back up to speed. Now when we spoke about decimal places, our focus was mainly on the decimal, on the digits that come after the decimal point. So, if I have a number, let's say 39.4721, and you were asked to round this off or approximate the number to 1 decimal place. That number is 39.4721. Then the first digit that comes after the point is 7. Sorry, pardon me, it's 4. So we will draw a line right between the 4 and the 7. We will therefore then, so this line, the purpose of this line is to separate what we want from what we don't want. But we need to determine whether this number should be increased by 1 or should we leave it alone. Now we're going to check the digit that comes right after that. And if that digit is greater than or equal to 5, we will increase this digit by 1, and so our final answer is going to be 39.4. Oh, 0.5. Okay? So once the digit that we check after is greater than or equal to 5, we increase the digit by 1. Now, let's say we have a number like 15.2837. and you were somewhat asked to round this off to now 2 decimal places. The second digit after the point is 8. So we then draw a line again right between the 8 and the 3. We will therefore check to see the digit that comes after. And like before, if this digit is greater than or equal to 5, you will increase 28 to 29. But since it's less than 5 in this example, we simply ignore the 3 and the 7, and so our final result here is going to be 15.38. What's wrong with me? I don't know, I'm not hungry, I'm just tired. 28. Now you're no mistake, promise it. Okay? So one of two situations is going to come up. Is that you're going to increase by 1 or you're going to ignore. Now we did look at a tricky example in our last class, okay, where we're dealing with the number 9. So let's say we have something like 111.9543. 111.9543. And we were once again required to round this off to 1 decimal place. The digit, or the first digit after the point, is a 9. So you draw the line right between the 9 and the 5. You will then check the digit that comes right after. And just like example 1, this digit is exactly equal to 5, so you would treat it as if it was greater than 5. You would then add 1 to 9, and as we discussed last class, you get 10. But 10 is not a part of our number system. Once you start from 0 and you go to 9, and you're ready to start, you have to go back to 0 again. So since 1 plus 9 is 10, we'll put the 10 right above here, right? Bring down the 0 where the 9 is, and add the 1 to the 111, and we get 112. 112. So it's 112.0. Okay? So this one's a little bit tricky. The concept of rounding off is easy. It's just that when you get this one and you add 1 to 9, you get 10. You can't put down the 10. You have to put down the 0 and carry 1 and add it to the digit before. Okay? So just look out for those in the examples. Now the rules for rounding off doesn't change, whether it be significant figures or it be decimal places. With significant figures now, we have to determine whether or not 0 or zeros are significant. And we have a discussion, a very elaborate discussion. Oh, this is recapping.
I wasn't here at the last class.
You sure?
I was here at the first one, but not the last one. So I didn't know what to do.
Oh no, it's just a title. It's just a title. Now we looked at the word significant, and the question was asked, what does the word significant mean? And the word significant means have a value, means important, means it's relevant, means it holds a position, it holds a significant position. Now when it comes to significant figures, the problem that most, if not all students have, is they tend to mix up when the number is significant from when it's not. So the example that we used was, let's look at three different numbers. Let's look at the number 10 or $10. At the moment this is $10. If I add another 0 here, it's 100. Add another 0, it's 1,000. Add another 0, it's 10,000. So as I'm increasing the amount of zeros that are in the number, the actual value of the number is increasing, which means that these digits, these zeros, are in fact significant. Now, the next number that we looked at was 0.1. If I add another 0 here, it is still 0.1. Add another 0 here, it is still 0.1. More zeros, more zeros, more zeros, the number is still 0.1. Which means that these zeros are insignificant. So then how are we going to know if it's significant or not? It's evident that if a zero or zeros comes after a digit that is not a zero, then they are significant. However, if a zero or zeros comes before a number that is not a zero, then it's insignificant. So what then if it comes between? Let's say you have a number like 0.0407. These first two zeros here are insignificant because they come before the 4. Okay? So these zeros, they don't have a value. You can't count them in your process. They have no value. However, this one is significant. Why? You can either say it comes after the 4 or it comes between the 4 and the 7. So you can't count these because however many of these zeros I add, you're still going to be insignificant to the number. But this one is simply because it comes after the 4, or better yet, it comes between the 4 and the 7. So the process remains the same. As long as the digit after is greater than or equal to 5, you will add 1 to the digit before. If it's less than 5, you simply ignore the digit that comes after the line. Example. Remember guys, for persons who are new, this is a recap from our last lesson, okay? This is a run through what we did in the last class. Alright, so now we have 253.287, and we should round this off to 4 significant figures. So 253.287, and that number is to be rounded off to 4 significant figures. My first significant digit is 2. My second significant digit is 5. The third one is 3, and the fourth one is 2. So a student might be here and ask, then sir, why didn't you start behind the point? When I start behind the point, I'm focusing on decimal places. But significant figure means that as long as the number is greater than 0, then it is significant. So my first one is 2, my second is 5, my third is 3, and the fourth significant figure is 2. So I will draw my line right after 2. That line is to separate what I want from what I don't want. So what I want are the digits on the left, what I don't want are the digits on the right. So I'll check the digit that comes after. This digit, 8, is greater than 5. So then I'll increase the digit 2 by 1, and so my final result is going to be 253.3. Is it clear?
Yes.
Is it clear?
Yes.
Okay. .007,461 or 7641, and I want this number to be rounded off to 1 significant figure. Now in this case, in this example, I can't start counting from the 0, because these zeros are insignificant. So my starting position, where I'm going to start saying 1, 2 significant figure is at the 7. So this will be my first significant digit, yes? I will then therefore draw a line right there to separate what I want, which is the digits here, and what I don't want are the remaining digits over there. But I need to determine, should I increase this by 1 or should I leave it as it is? I'll check the number that comes after that number is once again greater than 5. So I'll increase the 7 by 1, And so my final result is 0.008. Is it clear? It's clear. Give you a chance, right? Yes. Good one, see, Kingsley, I saw it. See, guys. Our final approximation was that we needed to write numbers in standard form. And in our discussion, we stated that a standard form is written in the form a multiplied by 10 raised to the power of n. It's a very strange way to write a number, but we did explain the reason why we write numbers like that. Simply because the number can be extremely large or the number can be extremely small. It just has too many digits to write down on paper. So for us to write this number in a more readable form, we write it in what we call scientific notation or standard form. Now there is 3 numbers that you may encounter during this process. You may encounter a number, for example, 876 million. That's a huge number. That's one number that you can, that's 876,000,000. You may encounter a number, let's say 0.000028714. Some of this kind of impractical to write that down on paper. And then you may encounter a number, something like 210.7218. One of these 3 numbers is going to present themselves. Okay? It's either going to be a number that forces you to jump to the left, or it's going to be this number that forces you to jump to the right, or it's going to be a number that you might have to contemplate, should I jump to the left or should I jump to the right? It depends. So in this case here, in our information that we have in our books, we said that A represents a very specific number. And that number has to be greater than 1, but it has to be less than 10. So the maximum that it can be is 9.9, and the minimum that it can be is 1. So how do I get 876 million to become a number that is less than 10, and at the same time less than greater than 1? We start out by identifying where the position of the point is. Now this is a whole number, a very large whole number that is, right? So when you see a whole number without a visible point, the point is understood to be at the end. Now our objective is to jump until we land right between the first 2 non-zero digits. So jump with me. 1, 2, 3, 4, 5, 6, and close. That's 876. 7, that's 87.6, and I get closer, closer. Boom, that's 8.76. So by jumping my point in that direction, we jump to the position where my number is now greater than 1 but less than 10. So at this point here I have 8.76. That is my A for this number. We're not ready to the rest of our thing. Let's figure out the A for this number now. Here's my visible point here. Now I can't jump to the left, because if we jump to the left this way, we have no more places to jump. So it's kind of automatic that I have to jump to the right. Jump with me. 1, 2, 3, 4. We're close. That is 0.2. But A has to be greater than 1 and at the same time less than 10. So now we'll jump one more time. Boom. That is 2.8. So now my number officially is greater than 1, but it's less than 10. So my A value now becomes 2.87. I can ignore the rest, those are irrelevant. I don't have to write down all of them, I just need to write them at least 2. So 2.87, right? That is my A. This number now, some people will say it must jump to the right, some persons will say it must jump to the left. Because some persons are visualizing this number as saying 7 is the first non-zero digit, while some person will understand that 2 is the first non-zero digit. So in this case, do I jump to my right or to my left? Here, right, here, left. Which one? Left. Right? Because the number 2 is my first non-zero digit. So I'm going to jump. Boom. Maybe at 21. That's still no less than 10. So I'm going to jump again. Boom. 2.1. So now officially, my new number now is 2.10. I can ignore the rest of numbers, digits, and that is my A value. So what we've just, the exercise that we've just done there is how do you determine the value of A? Is that you're going to get a number that you have to jump to the left, or you get a number that you have to jump to the right, or you get a number where you have to determine whether to jump to the left or to the right. So that is how I obtain my A value. Now if you notice that this is a constant value here, times 10. So at no given point is standard form going to be times 9 or times 8 or times 5. It's always going to be times 10 because standard form is a base 10 number. So this is going to be times 10, this is going to be times 10, and this is going to be times 10. So the only thing left now to calculate is what? N. And based on the information that is in your books, once you check your notes, you'll recall that N is the amount of places that you jumped or you moved. You with me? You with me? Okay. So N is the amount of places that you jumped. Let's take a look at number 1. How many places did I jump? Let's check again. 1, 2, 3, 4, 5, 6, 7, 8. So N is going to be what? 8. Now, is it positive or is it negative? Positive. Because of your notes you have in your book, if you check it back, it will say that when you jump to the left, it is positive. So this answer here is 8.76 times 10 to the 8. That is your standard form value. Is it clear? For this one now we need N. How many places did I jump? Let's count. 1, 2, 3, 4, 5. So we jump 5 places to my right. The question, is it negative or positive? Negative because I jumped to my right. So it's going to be negative 5. So that the answer is 2.87 times 10 raised to the negative 5. Okay? And then this last one here, it is very similar to number 1. We jump to the left again. So how many places did we jump? 2. So it is positive 2. Alright? So that is how you take any number and you write it in standard form. The concept is, and in summary guys, we're going to move on now. In summary, if you are given a number I think I have some new students, so I'm going to. Can you say redictate? Is that a word? I'm going to go back English. Is that word? Can I redictate what I said last week? That's all I one word, right? Alright, we'll make it one word. Alright, so I'm going to redictate for my students, giving you a summary of how we do this. Write this down for all new students. In order to approximate, students who were here last class don't have to write this. It's more or less the same information. In order to approximate any number in standard form, we must first determine the value of A. We must first determine the value of A. We must first determine the value of A. Full stop. A is obtained, and put A in open and close quotation so you don't confuse it later and think it means up. A is obtained by moving your point. A is obtained by moving your point to the left or right, by moving your point to the left or to the right in the direction, A is obtained by moving your point in the direction of the first non-zero digit. That is NON-ZERO, in the direction of the first non-zero digit. Full stop. So if your first non-zero digit is to your left, then you're going to jump to your left. If your first non-zero digit is to your right, you're going to jump to your right. So it's either left or right, you're jump. Okay? Full stop. Standard form is a base 10 number. Standard form is a base 10 number. And what I mean by that is it's always going to be A times 10. It's never going to be A times 9 or A times 8. Standard form is a base 10 number. So it's always going to be times 10. And then finally N. N, put it in open and close quotation. N, I'm just say it's common N, guys. N, common N, open and close quotation, is determined by the number of places. N is determined by the number of places that the point was moved. N is determined by the number of places that the point was moved. And then just to shorten the amount of information, draw one arrow like that, point it to the right, and you're going to write NEG above it. That means when you jump to your right, it is negative. And you draw one next arrow below it now and point it to your left and write pos, POS, positive. So when you jump the point to the right, it is negative. When you jump it to the left, it is positive. And that basically completes our topic of approximation. Okay? Now when you get a question, I may not necessarily give you a number and say, write it in standard form. I could ask you to do some calculation. Maybe I ask you to add, subtract, multiply, or divide something, and then when you get your final answer, further instructions are going to say, write your number in standard form. Okay? So that is it. That is it for standard form. That is it for approximation. So our primary topic for this class, now that we get everybody up to speed and the new people them kind of know which part of it. Okay? Kind of know which part of it. Our topic for today is percentages. 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 As I'm giving you some info to start off. A percentage is a fraction. A percentage is a fraction. A percentage is a fraction whose denominator. A percentage is a fraction whose denominator is always 100. A percentage is a fraction whose denominator is always 100. Full stop. The percentage formula is X percent, that is X with the percentage symbol, so that's X percent divided by 100, and you would therefore going to multiply this by the value of what we're finding the percentage of. So we could be finding the percentage of money that you need to pay down on an item. You could be finding the percentage discount that you're getting on an item you paid for. You could be finding the percentage of tax that you have to pay when you purchase something. Percentage is something that we do in almost everything. Even when you go into a store and it's like Black Friday or whatever the case is, that is this big red tab that says sale or things are on sale. You're taking a percentage of the original value. So when you're asked to find percentage, oftentimes you put the percentage over 100 and you multiply by the value or the original value of whatever you're buying or selling. Alright? So this is our percentage formula. Now just to make it clear, as I said, percentage is often placed in a box, and so most time persons don't understand that percentage spreads wide and far. So here's some examples of where you may encounter using this formula. Discount. Discount is a percentage. It's an amount, or it's a percentage amount taken from the original value of an item. 2. Tax. Tax is a percentage increase on the original value of an item. Commission. This is a percentage amount you receive when you make sales for a company. So let's say that you have a company that is selling these bottles, okay? And when you sell 10 of these bottles, the company is going to pay you a commission for what you've sold for them. So if you make one 10,000, then you want 2,000 extra for your pay because of how much you're selling. Profit is an example of percentage. So when you're buying and selling, when you buy something with the intention of selling it back, you're selling it in order to make what is called a percentage profit. And if you accidentally buy the item and sell it to less than what you buy it for, then you've made what is called a percentage loss. That's an example of percentage. And we can go all day, all night. And even for the adults that are in the class that may have taken out things from Singer, from Ports, right? Higher purchase, that's also a form of percentage as well. When them say, okay, let's say hypothetically speaking, you wanted to purchase the bottle, but the cost of the bottle is too much for you to afford. So them say you can pay down a portion of the money, or better yet, you pay down a percentage of its value, and then over time you pay for the rest, or you pay the balance in equal installments. So a percentage amount. Interest is also an example of percentage as well. So whenever you invest money into your bank account or into a firm, and the company say, all right, put 100,000, and after 1 year you get 10,000, then give what is called a percentage interest, right? So there are several examples of percentage that you're going to encounter. I've just chosen to list a few, right? Good. So occasionally now when I write a question for you on my assessment, it's not going to be something random like what is 30% of 500. That's just a startup question just to get you comfortable with the concept. But I'm going to make up some scenario and tell us a woman going on a store to buy one bag, and the bag is $1,000, and then so tax is added to the bag, how much the woman is going to pay for the bag. You know, I'm going to create some weird scenario around the whole concept of percentage. Right? Now, when I give you the percentage, the most basic form of percentage is when they give you the percentage as a whole number. Let's start off with this example. What is 30% of $150? What is 30% of $150? What I'm asking you, okay, because I find that many students, young and old, they struggle with interpreting what the question is asking you. So what is 30% of 150? I want to find out how much of $150 is equivalent to 30%. Let's talk about some basic percentage. If I ask you, okay, so the maximum percentage that anything has is 100%. So if I say to you, I want 50%, I'm technically asking you for half the amount. Not true? If I ask you for 75%, I'm asking you for 3/4 of the amount. If I ask you for 25%, I'm asking you for 1/4 of the amount. But when the percentage starts to fall between 25 and 50, when it begins to fall between 50 and 75, when it begins to fall between 75 and 100, or between 0 and 25, then calculations are going to be required. So for example, here we have what is 30% of 50? Since as they gave me the what? Percentage, I'm going to take the 30%, I'm going to divide it by 100, and I'm going to multiply it by the amount that I'm trying to find the percentage of, which in this case is 150. That's true? Now at this stage you have a choice, especially with certain numbers, right? 150, I can cancel if I want to, okay? Or if you're not very equipped at the timetable or you can't bother, okay? You can just simply say 0, cancel 0, 0, cancel 0. So you can cancel now, we just come up with fractions the other day, right? So we can cancel numerators with what? Denominators. So this 0 cancel this one, and this one cancel this one. So my final result then is 3 multiplied by 15, which is equal to $45. So 30% of $150 is $45. Give me a second, guys. Alright, so that's the basic form of percentage, right? So it doesn't matter what I give you now, it's not all the time you're going to get a number where you can do this nice, beautiful cancellation. Okay? You're going to get some numbers like, numbers with decimal points. So that's when you're going to be utilizing your best friend as a calculator. Now, can I make this question a little bit more difficult? Not really. Difficult is relative depending on your knowledge of the concept. So now I could ask you, as opposed to asking you what is the whole number percentage of a value, I can say something like, what is 12.5% of $1,600? What is 12.5 for those who can't see because of the marker? What is 12 and 1/2% of 1,600? Now there's two ways you can do this. I'm going to show you both ways. Then I'm going to tell you why I prefer one method over the other. At the end of the day, I'm leaving it up to you to decide which one you're most comfortable with. Remember, we're teaching all different kinds of people in this class. People who do what's long time, people who do what's right now, people who are young and green, fresh. So I have to try to reach everybody, yes? So now, what is 12.5% of 1,600? I'm going to do it the easy way first, the one where everybody will see it. Most students will know the decimal equivalent of certain fractions. Like if I ask one of my bishop students at the back, what is a half as a decimal? The most likely is going to tell me that it is what? 0.5. Right? And if I ask you again, what is 3/4 as a decimal? The most likely going to tell me that it is 0.75. Or if I ask you, what is a quarter? You're going to tell me that it is 0.25. So most persons who are fresh and green know that. But what about the person who was doing 10 years ago, 15 years ago, 5 years ago? Are we hitting maths like Python? They're not going to think about that on a regular, like what is a half or 3/4, okay? So we have to have an option for them as well. Not sure? And what if, so for this one, 12.5, it's easy for anybody to say 12.5 is 12.5 over what? 100 multiplied by 1,600. Not sure? Very simple. 0 cancel 0, 0 cancel 0, and you just max up that by your calculator and you find that 12.5 multiplied by 16 will give you $200. Basic, not true? It's very basic. Alright? And that is when you know the decimal equivalent of the fraction. I could give you a weird fraction. I could ask you what is 9 2/3. Now watch this. If I ask one of my, I say most bishop students in here. Let's say I ask one of my Mount St. Joseph students now, what is 2/3 as a decimal? They know about shuffle. They know if and but. Or they're using the calculator there. What is 2/3 as a decimal? Most persons is not going to know that it is 0.6. Or what is 3 4/5? Most persons are not going to know that 4/5 is 0.8. So when you don't know, how do you go around this problem? What if you don't know how to use the calculator? What if you don't have a calculator to use at that point in time? Is there a way to work out the question? There is. Same question we're going to do. In our last topic where we were talking about fractions, one of the rules, the very first rule that we mentioned was that once you see a mixed fraction, convert all and any mixed fraction to an improper. So we could, so this is option 1, this is option 2. Okay? 2 times 12 is 24. 24 plus 1 is what? 25 over what? 2. And here's where majority of my students over the years have gotten caught. So the moment them say 25 over 2, them just go boom and say times it by 1,600. And completely forget that you have to divide this by 100. You cannot forget that the 25 over 2 is just another way of writing the 12 and a half. And since as they did put the 12 and a half over 100, when you rewrite the 12 and a half or 25 over 2, you still have to put it over what? 100. Because this is saying 12 and a half percent. 12 and a half over 100. This is the part that the students always forget, to put it over 100. Okay? Now, if we can get to this stage, you're going to find that this is not something that comes up on a regular. Okay? Because most times if you go in a textbook or you go on Google and you type in percentage worksheet, PDF, a document comes up and a bunch of questions come up, and you're going to find that majority of the time the percentage is always a whole number. What is 25% of 500? What is 40% of 200? What is 60% of 900? What is 75% of 800? I always whole number in my video. Unless you specifically type into Google percentage worksheet with mixed fraction, then now come up. Okay? So this is not normal. No. I have a few questions for you guys. What is the bottom number of any fraction called? Bottom number of every fraction is called the denominator. So I'm going to ask you some questions and you can either agree or disagree. Okay? Is this 2 a denominator?
Yes.
Good. What is one I don't agree? Is this 100 a denominator?
Yes.
Beautiful. So if I have the 2 as a denominator and I have the 100 as a denominator, well, we can combine them and make them one denominator. So I can simply write down now, watch this time now. We're going to write 25 over, watch this time now. Slide this downstairs and merge it together and you get 200. So you get 25, not over 100, but over what? 200 and times it by what? 1600. So you are allowed to do that because you have 2 denominators. You can combine them and make them one and combine or merge in math instead of multiply. So then let's see if we get the same answer. Not true? 0 cancel 0. 0 cancel 0. 2 into itself 1 time. 2 into 16 8 times. 25 times 8 is 200. So the same answer. Of course, if I ask you now which method you prefer, I'm going to say hands up. Everybody will say method 1. True or false?
True.
Method 1.
True.
So much hands? Everybody prefer method 1. Now in the next 3 minutes, all those hands going up will go down. Watch. I'm not sure you know. So if you think you're going to get it easier all the time, all those hands that went up, you're going to hear someone about, sir, I prefer method 2, yes sir. Method 2 easier. So changing this number here from 12 and a half to a weird looking number now. 8 and 2/3%. And I'm going to change this now to 300. So I want to find out, and this is an assessment question. Okay? It's a question that is worth 2 marks in the exam. And many persons will get it incorrect. Okay? So 8 and 2/3%. Of course, I'm going to cater to the people who love the calculator. Right? So, if you like, if you prefer the calculator, of course you can go on your calculator and you can type 2 divided by 3 and get 0.6. So it's not a case where you have to know what is 2/3 or 4/5 or 5/8. You can just go on your calculator, type in 2 divided by 3, they're going to tell us you have 0.66666, and then when you put it with the 8, you get 8.66666. So if you want, you can convert the entire percentage to a decimal. Or you can just do like me. 3 times 8 is 24. 24 plus 2 is what? 26. And normally I would put it over what? 100. But because the denominator are what? 3, I'm going to put it over what? 300. So we cut my work short. Because we know it's going to be 26 over what? 3 over what? We already know that. So since as we know, we can skip out that step and just say 26 over what? 300 and times it by what? 300. Knock out this, knock out that, the answer is what? 26 minutes. So now I can give you, at this point now, I can give you any random, weird looking mixed fraction. Even if it don't make sense to you, I can give it to you. So let's say I ask you in my assessment next week, can you guys see that? I don't think so. So let's say I ask you next week or in the near future, right? Could be anytime throughout the year. What is 15 and 4/5% of 1500? What is 15 and 4/5%? This is not a normal question that you get, right? But you get it. You will get it, especially on an assessment. Because now they might test not only your percentage skill, but you're testing your application of fractions skill in another topic. So they might test the transfer of learning. Okay? So here, I could go on my calculator and I could say 4 divided by 5, and it's going to tell you 0.8, and then you'll end up with 15.8. So you can go ahead and say 15.8 over 100 times 1500, bam, 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 and get the answer. Easy, no problem. Or you can do like me. 5 multiplied by 15, that's 75. 75 plus 4 is what? 79. And on a normal basis, I would say over 100. But because my denominator is what? 5, it's going to be over what? 500. And then we times it by what? 1500. Not true? Bam, 500 into itself goes what? 1 time. 500 into 1500 goes what? 3 times. And so you max up that 79 times 3. How much you get? 237?
Yes.
Flat?
Yeah.
Yeah, obviously, yeah. $237 flat. And that's my answer. Now, why do I prefer that method? I did promise you I'm going to tell you why I would prefer this method. For those who have done exams before, or for those of you guys who are going to be doing exams in the future, there's a section of the exam called multiple choice, where you're not allowed to use a calculator. You don't have access to one. So when you're the one that really, why certain camera method is too long, and you want to use the calculator, what then if you're not allowed to use it? Anybody here doing City and Guilds? In the future? City and Guilds, depending on what level you're in, level 1, level 2, I'm not sure of the levels, but different levels, some levels will tell you you are not allowed to use a calculator. For CSEC, multiple choice, you're not allowed to use a calculator. And this is a typical question, love symptom. And when you calculate it incorrectly, there's an answer there for you to circle. Once you do anything wrong on multiple choice, whatever you do wrong, there's always an answer there for you to circle. So you want to have options, guys. Options. Okay? I like working it with the decimal method because it's easier when you use it on a calculator. But what if you don't have a calculator? That's an option. Is it clear? Okay? Alright, I'm going to give you one to try. Give yourself some readings for this. So try this one for me. What is $25 what is 25 and 1/5% of 2,500? No, I'm trying to make it too difficult. I just want you to be able to use this method to your advantage. What is 25 and 1/5% of 2,500? For those who can't see, 25 and 1/5% of 2,500. Alright, so calculate the person's 1/5 is 0.2. So if you did say 25.2 over 100 times 2,005, you should get the answer. Or 5 times 25 is 125 plus 1 is 126. As opposed to going over 100, we go over 500 times 2,500. Now 500 into itself one time, and 500 into 2,500 goes 5 times. And you just max up that, and you should get what? $630. Go. Got it? You made an error? Yes. Got it. Good. I think most of you guys got it. Most got it. Okay? Now, so far all our examples have always been to divide by 100. But there are percentage questions that requires us to multiply by 100. And this is where the confusion comes in, okay? For most students. As I said, when I'm speaking in general. So the cap may not fit you. Okay? You may be just that student who knows when to divide and when to multiply. So head up for me. Subheading, expressing a quantity. Subheading, expressing a quantity as a percentage of another. Expressing a quantity as a percentage of another. That's the heading. Still on the topic of percentage. Expressing a quantity as a percentage of another. Now a very common example of this one, a very common example is when let's say I give you an assessment next week. Right? I'm using my students here as an example. New. Let's say I give an assessment next week and the question or the paper is marked out of 30. So all the questions and the points awarded to each question accumulates to 30 points. And he ended up getting 20 out of the 30 points. The question is going to be, what is his percentage? So we don't get 20 to 30, but what is that percentage? What is that 20 as a percentage of 30? So we could create that scenario, use that scenario. Okay? So we could say, what is your name? Jamar? Jamari? Yes. Okay. So to write a question using Jabari's name, we could say Jabari scored 20 points. Let me just write this with another color. Jabari scored 20 points on his recent math exam, which had a maximum of 35 points. Calculate Jabari's percentage mark. So Jabari scored 20 points on his recent math exam, which had a maximum of 35 points. That means if you get 35 out of 35, you would get 100%. But you get 20 out of the 35. So we want to know what is his percentage score. So to solve this question, we take Jabari's score, which is 20. We don't divide it by 100. We divide it by how much was the maximum. Okay? And it's the same thing with the other question. Remember that percentage is out of 100. That's why we always divide by 100, because the maximum mark in a percentage is 100. But the maximum mark for Jabari in this maths exam was 35. And then now you have to times it by 100, because we are looking for his percentage mark. So one question is going to tell you the percentage, and the other question is going to ask you for the percentage. So when I'm asking you for the percentage, you're going to multiply by 100. You can do whatever fancy stuff you want to do here. You can say 5 into this 7, 5 into that. You know, at some point you're going to use the calculator anyway, so I'm just going to proceed now to ask you to type all of this on the calculator. You can say 20 times 100 and divided by 35. Or you can say 20 divided by 35 times 100. 6 or 1/2 dozen is the same thing. What you got? 57%. And that is his percentage mark. That's not a premonition for next week. We're going to get 100 next week. Right? That's your way. You're not going to get 57. So that is his percentage mark, 57%. So I'm going to give you a question and see if you can interpret it. Okay? Let me give you a question that is similar to this picture. I need another student's name. What's your name, my friend? I'm going to make a question. I like to use my student's name in my exam. Oh, Jesus. No one easy name. Anybody want a Jamaican name? Like Sasha, Paul, or something? Funny. Stephanie. I know you. Somebody. Ready? Are you going to use Stephanie? Stephanie. I know you miss her. Stephanie. Any Stephanie here? Is that man up to me, man? Check. Stephanie. Or Sasha, right? Whichever you know what. Right? Stephanie read, R-E-A-D, past tense of read. Stephanie read 47 pages. Stephanie read 47 pages of a book containing Stephanie read 47 pages of a book containing 190 pages. Of a book containing 190 pages. Full stop. What percentage of the book, is left to be read? What percentage of the book is be read? That's the question. See if you can figure that one out. Register? Nelson, is there a Nelson in here?
I think your mom's doing this with
Alright, so go ahead and try to see if you can at least get somewhere with that question. If I even halfway, I'll come and meet you halfway. Jack, how much everybody stage? Did you get 75% approximately?
Yeah.
74 point something? 76 point something? No? So to get 76 and change, but we are rounding it off to a whole number so we get 75. How? Here, how? I don't doubtful, so did you get 25?
Yeah.
At 24? Right, so this is where the English comes in. The 25 represents how much she read. The question says how much she have left to read. Get the question? I told you she read 47 pages out of the 190. So when I'm assuming that you put 47 over 190 times by 100, you get 24.7, right? What does that mean? It means that that's the amount of the book that she has read thus far. The question says, how much of the book is left to be read? That means you have to take the 25 or the number that we get, 24.7 from 100. That is English, that's not math. Does not do the maths, right? It's just the English you didn't get. Okay? So let's go. So everybody, I'm assuming said 47 divided by 190 and you times it by 100. True?
Yes, sir.
0. Not you know I'm not times that. Punch it on the calculator, you get 24.7, which is approximately equal to 25%. You need to understand what this means. That's the interpretation. The 25% mean, it means that that's the amount of book, that's the amount of the book that has been read thus far. The question follows by saying, how much left? How much of the book is left to be read? How much more she has to read? She has to read 100 minus what? 25, which is approximately equal to 75%. Right? 75%. Now there's another way to do this. Give me a time check, guys, because I think my time is almost expired. 5:18. Alright, so not it. So there's another way to do this. Like I said, you can do it from the other direction. Since as we know, okay, so the question that you're trying to answer is how much of the book is left to be read. All you have to do is just find out how much page she have left to read. Not sure? So we know that she read how much page already. And how much pages the book have?
190.
So we can just calculate how much page she have left to read. If you max up that, you should get 143.
Yes, sir.
So she has 143 pages left to be read, don't you? Boom. So since she has 143 pages left to be read, out of a total page of what? 190, you need just multiply that by 100, and when you do the maths, you tell us the answer is 75%. Right? So that is the concept behind it. Now, today what? Tuesday? Alright, so I guess over the course of the weekend I'll send you, I already sent you questions on fractions, questions on decimals. So over the course of the weekend I'll send you some questions on approximation as well as some percentage questions over the weekend. Along with whatever we're going to do on Thursday. Thursday we're going to go into a topic known as direct and indirect proportion. So if you have an industrious outgoing student who want to go ahead and read them, find that. Getting that after the assessment. Okay? Okay, so after we do the first assessment, then we know everybody there, then I'll have an idea of, all of that will be discussed in the class. Alright, have yourself a good evening, everybody. The class is recorded, so if you still need a review on what we discussed today, you can always visit my YouTube channel and you'll find it. Alright? Okay, the YouTube channel name is, for those who don't have it, Apex Institute of, once the typing it comes up, mathematics. Okay? And tell all your friends them as well. Okay? Apex Institute of Mathematics. Type that in on YouTube. We're already there 500 people already, so you have to find me easily. It's a logo with a yellow graph with a graph. You just subscribe and do the right. Okay? You'll see this class tomorrow evening in the night. You get it right? Listen. There's a WhatsApp group, so you can go downstairs and let them add me. There's a WhatsApp group, so you can go downstairs or just message me and add me. 2207352. Just send me a message on WhatsApp and I'll send you the link to the group. Apex Institute of Mathematics. Apex, so some Apex. Hold on. It's just in my head. I don't remember this because I'm going to have the right one. Shit. I was messaging me about switching my 9 days on 9 shift bar. Never use it. So, what do we do? You can press